These are calculus notes on slope fields. We're going to define what a slope field is, take a look at how to create one, and how to answer some questions about them. First of all, a slope field is a visual representation of all solutions to a differential equation. A differential equation, that's just a derivative equation. So we are going to be given an equation of a derivative, and we are going to sketch a representation of all the solutions. So remember, when we integrate, so if I were to integrate this, I'd get x cubed minus x plus c. I'd have that plus c. So because I have plus c, there's not just one specific y value that has this derivative. We're going to sketch all the possible solutions, and not the actual solution itself, but we'll have little bits of each solution. So when we're asked to sketch a slope field, we're going to be given the points that we need to sketch the slope field at. For this one, we're going to go out to 2 and down to -2 in both the x and the y. This will be given to you here soon. We will start to take a look at some AP problems, and on the AP exam they'll actually put dots at all the points where they want you to sketch the slope field. So we're going to go with all the x values between -2 and +2, as well as the y values between -2 and +2. So in this case, we've got 25 different points where we are going to sketch our slope field. Usually it's less. This one's got a little bit more. So part A is asking us to create a slope field for the differential equation. So all you're going to do is take a point, let's start with 0, 0, and you are going to plug it into the differential equation, into the derivative equation. So if I plug in 0 for x and 0 for y, and notice this one, there's nowhere to plug in the y. So if I plug in 0 for x, I get a slope, dy dx equals -1. So I need my slope at 0, 0 to be -1. So I'm just going to draw a small line segment that has a slope of -1, down 1/1. So it should be pointing at those points there. Notice at 0, 1, if I plug in 0 for x and 1 for y, I also get -1. Also at 0, 2, and 0, -1, and 0, -2. If I plug in 1 for x, no matter what I plug in for y, I get a slope of 2. So up 2/1, I should be pointing about at that. Doesn't need to be perfect, but it should have a positive slope, and it should be a little steeper than the -1 was. If I plug in 2, I get 4 times 3, 12 minus 1. I get a slope of 11. So it should be kind of close to vertical. Again, it doesn't need to be perfect, but something like that will do. Plugging in -1 for x. -1 for x also gives me a slope of 2. -2 for x also gives me a slope of 11. And that is our slope field. Notice if I were to follow these slopes, I would get a graph that looks something kind of like this. And then it's going down here, and then it starts to go back up. It gets steeper and steeper. Notice if you follow these little slopes, I get a cubic function, which makes sense because if I integrate this, I get x cubed minus x plus c. Part B asks us to find the particular solution that has the initial condition f of 2 equals 4. So we want to know what function has this derivative and passes through the point 2, 4. We've done problems like this before, we need to go from the derivative to the function. To do that, we are going to integrate 3x squared minus 1 dx, giving us x cubed minus x plus c. And we need to pass through the point 2, 4, so I'm going to plug in 4 for f of x and 2 for x. I get c equals -2. So my function is x cubed minus x minus 2. Notice that function, if I take the derivative, I get 3x squared minus 1. And if I plug in 2 for my x's, I get 4. Part C asks us to write an equation for the tangent line passing through the point 2, 4. So very similar problems. They both give me the point 2, 4. This one wants the solution itself. So that one's the curve. This one wants a tangent line. So if I have my curve that passes through 2, 4, 2, 4 is up here somewhere. So I have a specific curve that passes through that. Now I want the tangent line to it. So the tangent line is a line. It's not a curve. So I need to find a line that passes through the point 2, 4 and has a slope of 3x squared minus 1. So I know my point. I need a slope. We already found the slope at this point. When I plugged in x equals 2, remember I got 11. So we need an equation that passes through the point 2, 4 and has a slope of 11. Didn't say we had to write it in slope-intercept form. Usually it's a good habit to be in to go ahead and do that. 11x minus 18. Example 2, very similar problem. They give us dy dx equals the quantity x minus 2 times the quantity y minus 1. And they ask us to create a slope field at these 16 points. Go ahead, pause the video. I want you to try that. Once you think you have it, start the video again. You can check versus what I have. Notice anytime x equals 2, I get dy dx equals 0. So all the x equals 2's have a slope of 0. Also, all the y equals 1's have a slope of 0. So we have a bunch of slopes of 0. And then we can start plugging in the other points. If I plug in 0, I get -2 times -1. That's +2. Plugging in 1, 0 gives me -1 times -1 is 1, and so on. -2, -4, -1, -2. That one's 1, this one's 2. So notice this one, you have to plug in both the x and the y because you have both x and y within your differential equation. So there's the slope field. Part B, similar to part C on the previous problem, asks us to write an equation for the tangent line. We want it to pass through 3, 2. At 3, 2, we had a slope of 1. So y minus 2 equals 1 times x minus 3. Y equals x minus 1 is the equation of the tangent line.